Okay, good day everyone and welcome to GCSE topic, Surds. So, we're going to do the square root of 98. How do we simplify this? Okay, when we're simplifying Surds, what we need to know is that it's just like simplifying fractions. We're just writing it. And remember, when we express something in a different form, we don't change that actual quantity. For example, the number 4 can be expressed in a different form as 2 plus 2. 2 plus 2 is still 4. I can also express it as 2 squared. That is also 4. I could even express it as 3 plus 1, which is 4. So whenever I express something in a different form, I'm not changing the quantity. So question 1. Express square root of 98. Now, what do I know about square roots? Okay, it wants us to put it in the form where we have a whole number and then we still have a square root, which we call a surd. So, the only way we know, for example, that the square root of 16 is actually going to give me 4. So what I actually want to do is I need to find a square number that is a factor of 98. Now, I know the factor of 98, that's also a square number, is 49. So I can rewrite 98 as the square root of 49 times 2. Using the laws of surds, this is also the same as square root of 49 times the square root of 2. I know the square root of 49 is 7, so I'm going to have 7 times root 2, and then I can simplify that as 7 root 2. There we have it. I have now expressed this in the form a root b, and I haven't changed the quantity. Okay, the next question. It wants us to express root 48 plus root 108 in the form k root 6, where k is a surd. First of all, we're going to do what we've been normally doing. Okay, 48. How can we represent that as two factors where one of the factors is a square number? What do we have? 48 is? If we divide it by 3, what do we get? 16 times 3. So this is root 16 times the square root of 3, which is 4 root 3. Is everyone happy with the first step? Okay, the second part. Square root of, I'm not going to worry about the rest of the question, I'm just going to simplify both. Square root of 108. What numbers multiply to give me 108 where 1 is a square number? 36? Perfect. So 108 can be written as 36 times 3. So this is 36 times 3 is square root of 36 times the square root of 3, which is 6 root 3. Because we know the square root of 36 is 6, right? Okay, forget about the question for the moment. We're just going to look at this. So 4 root 3, and remember this was a plus here. So 4 root 3 plus 6 root 3. Now remember, root 3 is just a decimal, isn't it? So if I've got 4 lots of a decimal plus 6 lots of the same decimal, how many lots of the decimal do I have? 10. So this becomes 10 root 3. And the way you have to treat this is, you know, when we use algebra, okay, if we had 4x plus 6x, we know this simplifies to 10x. It's the same when we have surds, which are the same, because remember, x represents an unknown quantity. X here could be 2, right? Well, this x, you know, the x here would also be 2. So this is how we get 10 root 3. Is everyone happy with this? Yeah. Now it says I have to write it in the form k root 6. Okay, do we have a root 6? No, we have a root 3. How could I get a root 6? Times 2. But I need it to be back in the square root, don't I? Okay. So I really need to think about, how can I now go backwards? Okay, so we've had a few people saying divide by 2, multiply by 2. However, we can't change the quantity. If we multiply this by 2, we're actually doubling everything, aren't we? And we can't double it. We can't change the quantity. We need to think about the facts that we know. So, here we go. What do we know? We always go back to what we know. 10 root 3. If we want to write 10 as a square root, this is the square root of 100 multiplied by the square root of 3. Have I changed the quantity? No. Square root of 100 times root 3. I could rewrite that as the square root of 300, couldn't I? I'm going backwards. They've asked me to have a root 6. Okay, so root 6 times what is 300? 50. Okay, so I now have root 6 times root 50. Okay, there's my root 6. So if my k is a surd, what's my k? Root 50, right? So I could leave this as root 50, root 6. This is in the form k, k root 6, okay? So we can see here that our k is root 50, yes? However, does anyone know what root 50 is?
Yes. 5 root 2.
5 root 2, yes! Because root 50 is the square root of 25 times 2, which is the square root of 25 times the square root of 2, which we know is 5 root 2. So we could actually write this as 5 root 2 root 6. Okay? And our number, and this is now our k. Our 5 root 2 is our k in its simplest form. However, root 50, did it say simplest form? I can't remember. No, it just says where k is a surd. So if you'd have written root 50, you'd still get full marks. It didn't say a surd in its simplest form, did it? And if you went one step further and did 5 root 2, that is also okay. Yeah? So can you see how I've used the knowledge and gone backwards? Fantastic, isn't it? Okay, give question 3 a go. Off you go. So the square root of 27 is in fact the square root of 9 times 3, because 9 times 3 is 27, right? What's the square root of 9? 3. So this is the same as the square root of 9 times the square root of 3, which is 3 root 3. Brilliant. 147 is 49 times 3. Square root of 49 times the square root of 3 is 7 root 3. And remember, we're going to add these together. So, 3 root 3 plus 7 root 3 is in fact 10 root 3. There we go. Okay, before you give this question a go, does everyone know how to expand a double bracket?
Yeah.
Okay, well then this should be easy then. Are we ready? Off you go. Okay, so let's now give this a go. So first of all, what do we know about expanding brackets? Everyone does this a different way, okay? I'm going to do it this way. 7 times 5. 35. Perfect. 7 times minus 2 root 2 is minus 14 root 2. Okay? Minus 14 root 2. And the way you can think about it, imagine this was 7 multiplied by negative 2x. Remember, this root 2 is essentially an x. It's the square root of 2 is what we're representing as a decimal. Yeah? We're representing this decimal as root 2. So this is, what is 7 times minus x? Minus 2x? It's minus 14x. It's exactly what I've done there. Yeah, 10 square root 50. So 2 root 50 times 5 is plus 10 root 50. Okay? Now the last one is 2 root 50. 2 root 50 times negative 2 root 2, which is 2 times 2 is negative 4. Root 50 times root 2 is the square root of 100. So minus 4 root 100. Okay, now we need to simplify, expand. But that first step was just multiplying. Okay, just like we would normally multiply. Now the second step. Okay, 35. Can we simplify 35? No, it's just 35, so I'm just going to leave it as 35. We don't need to simplify this number. Minus 14 root 2. Is root 2 a simplified surd? Yes. So this is minus 14 root 2. Root 50. No, it's not. Can we simplify that even more?
5 and 10.
5 and 10, yeah. Root 50 is 5 multiplied by 10. How does that help me, though? Because I would like one of the factors to be a square number.
25.
Yes, 25 and 2. So this is the same as the square root of 25 times the square root of 2, isn't it? Which we know that's the same as 10 lots of 5 root 2. What is 10 lots of 5 root 2?
50 root 2.
50 root 2. So you can see how we've simplified that. Okay. The next one, minus 4 root 100. What is root 100? 10. This becomes minus 4 times 10, which is in fact minus 40. Okay, so now I have a look. Right. My number's simplified. I have 35 minus 40. What does that give me?
35 minus 4 minus 15.
Minus 5.
35 minus 40.
Minus 5.
35. I got 35.
Then the next one we have is minus 14 root 2 plus 50 root 2
Minus.
No,
Yeah.
36.
Minus 64.
36 root 2.
plus 36 root 2.
It's minus.
It's minus 14 plus 50 root 2. Yeah, no, it's not minus. So it's minus 14 root 2 plus 50. Sorry, my presentation here is actually shocking. However, it's because I wanted to show all the steps. So now we've simplified it. Now, here's the issue. A plus B, but what does it want? Root 18. What do we got? 2. Right, so I'm going to go backwards, okay? As long as we get to this stage, we're all good. Okay, now let's go backwards. We want it root 18. So first of all, what is 36 squared? No, 36 squared. Yeah, someone needs a calculator for this. I can't do this in my head. So, 36 squared is the same as
1,296.
1,296 times the square root of 2. Okay, what is 1,296 times 2? 2,592. Okay, once it's square root 18, right? I'm going to divide this by 18. If I divide this by 18, 1, great, and we know what 144 is. 12. Okay, so this is root 18 times root 12, times the square root of 140, which we know is 12. There is no root 12. Okay? So actually, 36 root 2 can be written as 12 root 18. So the final answer is minus 5 plus 12 root 18, because we went backwards. Now, there is definitely a quicker way to do this, and a more logical way to do this. However, when you need to discover this, I'm just going to show you the long way that makes sense. You need to discover how to make this slightly quicker. Okay, we will get there towards the end of the questions. So, now, this is the final answer. Okay, minus 5 plus 12 root 18. However, in the exam, it would ask you to do it in root 2. So if you got to this stage, you're winning. This is just that extra bit to see if you can manipulate the surd. Okay, so there it is. So for question 5, going to do the same again. Remember, 6 minus root 8 squared can be rewritten as 6 minus root 8 multiplied by 6 minus root 8. And you have to show that it equals this. So when you expand and simplify, this is the answer. Off you go. Okay, so here we go. We're going to start expanding. So we're going to get 6 times 6, 36. 6 times negative root 8, negative 6 root 8. Negative root 8 times 6, minus 6 root 8. Minus root 8 times minus root 8 is plus the square root of 64, because we know that root 8 times root 8 can be written as the square root of 8 times 8, which is the square root of 64. Now, I also want to show this in a slightly different way as well, so we're just going to do a quick side note. Okay, side note. So some of us then have just done the square root of 8 times the square root of 8. And we've written it out, you know, when we've done this method, root 8 times root 8, root 64. However, if I was to write the square root in an index form, okay, I call this an indice form, we know square root is to the power of a half. This is times 8 to the power of a half. When the bases are the same and we're multiplying, what do we do to the powers? We add the powers, absolutely. So this actually becomes 8 to the power of 1, which is in fact just 8. Now we can see this proven over here by using the laws of Surds. So we know root 64 is in fact root 8. So you can see how we've done that different way by linking different topics. Okay? So we should have all got to this stage. Now from here is the key part. We need to now expand and simplify. So we've expanded, so 36. What's minus 6 root 8 minus 6 root 8? Minus 12 root 8. And the way we can think about this as well, if we're a little bit confused, minus 6x is minus 12x. Yeah? Root 64 is in fact 8. Okay? Now, is the square root of 8 in simplified form?
No.
No. We know the square root of 8, so root 8 is the same as the square root of 4 times 2, root 4 times root 2, which is 2 root 2. So this is 36 minus 12 lots of 2 root 2 plus 8. Okay, what is, collecting like terms, 36 plus 8? 44. And then minus 12 times 2 root 2 is in fact minus 24 root 2. Is that what the questions asked us to show? Yes. I've got the answer, and they're going to put therefore shown. Absolutely fantastic. So here we go. Question 6. Show that root 48 plus root 108 can be expressed in the form a root b. So we want this as simple as possible. So for root 48, I'm going to look for the highest factor that's a square number. 16? Yeah. Root 16 times times 3. Okay, now it's really important is to show that question. We need to show our steps. You can't just put this into the calculator. You can put this into your calculator to check that you've done it right. Okay? So this is the same as root 16 times root 3. What is the square root of 16? 4. So this becomes 4 root 3. Perfect. We've now done that. Okay. Square root of 108. Now, guys, this is called common sense. Okay, here's common sense for you. I am 95% sure that this 108 will be a factor of 3 because we've got a root 3 here, right? And so I'm going to divide it by 3, and actually I'm going to get 36 times 3, which 36 is in fact a square number. So I'm going to get 6 root 3. Hey, did we do this question yesterday?
Yeah.
Well, okay, it's a bit different. However, 4 root 3 plus 6 root 3, how many root 3s do we have? 10 root 3. There we go, extra practice. Brilliant. Okay, let's move on. So with this, okay, we're going to start with how we'd normally multiply 2 brackets, yeah? So to start with, let's just focus on this. We're going to do 5 times 6. 30. 30. 5 times negative root 3 minus 5 root 3. Okay? Minus root 12 multiplied by 6. Minus 6 root 12. Minus root 12 times minus root 3. So first of all, this becomes positive. Okay? And then root 12 times root 3. It's the same as the square root of 12 times 3. Remember, it's like going backwards. Which is in fact root 36, which we know is 6. So we know that's simplified to 6, right? However, is root 12 fully simplified? This is the same as minus 6 bracket. Root 12, we could write that as 4 times 3, right? Which is root 4 times root 3, which is 2 root 3. And what is minus 6 times 2 root 3? Minus 12 root 3. Okay? So now every term is simplified. So I have 30 minus 5 root 3 minus 12 root 3. Now we simplified it. Yeah. And then plus 6, because we simplified this as well. Okay, now we collect like terms. So we have 30 plus 6. What's 30 plus 6? Brilliant. And then we have minus 5 root 3 minus 12 root 3s. How many root 3s do we have? Minus 17 root 3. Now what we find is when we look at the question, actually, the question says show that this is equivalent to 36 minus 17 root 3. Here we have 36 minus 17 root 3. We've shown that they're equivalent. Okay? And then if you want to, you can write therefore, proved, or shown. Okay? So here we have a question. You can clearly see we have a fraction. Okay? Now what they want us to do, they want us to express this in the form root k. All right? Okay, so what we're actually going to do is something called rationalizing the denominator. Okay? And it's because a surd is not a rational number. Okay? A rational number is a number that can be written as a over b, where a and b are integers. For example, 0.25. This is rational because we could write this as a quarter. Yeah? However, if you square root 2 and put that into your calculator, we get something like 1.4 or so. I mean, I can't even remember. But however, you know, sometimes you put a calculation into your calculator and it gives you a fraction. That's called a rational number, and then you press SD to find the decimal. Yeah? However, sometimes you put a calculation in and what you get is a decimal. Yeah? That is not a rational number, because it means we can't write it in the form of a fraction. So it will say rationalise the denominator. It means we don't want a surd on the denominator. Okay, we want this to be a whole number. Okay, not a decimal, we want this to be like an actual number. So for this type of question, some of you have already started doing this and you got as far as you could. I'm really impressed. So what you decided to do was simplify the numerator to see if you could do that. Now we actually can on this question, because root 3 plus root 27, if we do that over here, this is the same as the square root of 9 times 3, root 9 times root 3, which is 3 root 3. Brilliant. So we get 3 root 3 over root 2. Root 3 plus 3 root 3, how many root 3s do we have? 4 root 3 divided by root 2. Now this is a perfect first step, and I'm really proud that we got this far, okay? However, how am I now going to manipulate this so that the quantity is the same, as in we're making this equivalent? We're going to represent this different. We're not going to change the quality. For example, we could represent the number 5 in a few different ways. 4 plus 1, square root of 25, okay, 2 times 3 minus 1, okay, Do all of these equal to 5? They're just all represented different. This is what we're going to do with this right now. We need to represent this differently. However, we cannot change the quantity. Okay, so I want you to stop and think about that for a second. How could we represent this in a different way where we don't change the quantity? Okay, so 4 root 3, actually before we do this, okay. What is 4 divided by 4? 1, brilliant. What is x divided by x? Brilliant. What is root 3 divided by root 3? 1. Okay. What is 5 times 4 over 4? 5. Brilliant. What is 5 times x over x? Brilliant. What is 5 times root 3 over root 3? Perfect. So can you see, actually, what we're doing here is we're writing 1 in a different way. And any number multiplied by 1 is still the number, right? So have we changed the quantity? So this is what's really important. And this is actually pretty magical, okay? So what we're going to do then, just like when we do equivalent fractions, we're going to have 4 root 3 divided by root 2. And we're going to multiply this by root 2 over root 2. Because we know on our denominator, root 2 times root 2 is just going to give me 2. And then have we got rid of the surd? Yeah, we rationalized it. Okay, so multiplying by this, actually we're multiplying by 1 whole 1. Have we changed the quantity of this? Isn't that just wonderful, magical? So 4 root 3 times 2 is going to be 4 root 3 times root 2 divided by root 2 times root 2. Okay, I'm just going to do it a bit of the long way so we can see how it's simplified step by step. We know that square root of 3 times the square root of 2 is the same as 4 multiplied by square root of 3 times 2 over, and root 2 times root 2 is in fact 2. Okay? Now, this is going to leave me with 4 root 6 divided by 2. Okay, we need to remember that actually 4 root 6 divided by 2. Imagine again, if you had 4x and you divide that by 2, what do you have? 2x. So if we have 4 root 6 divided by 2, 2 root 6. Yeah? This is why I always remind us about x. Remember, root 6 is just a number. Root 6 is a number. This is a decimal. And I always refer back to algebra because imagine our root 6 here is an x. Because just like you said, you've just then said, oh, this must be 2 root 3 because you've halved the root 6. We cut. If you think that's physically impossible, yeah? If you had 4 bags of rice and you split them into 2 groups, how many bags of rice have you got?
I got 2.
Yeah, you've got 2 bags of rice, right? What you've just said then is if you had 4 bags of rice and you split them into 2, you have 2 half bags of rice. Do you see? And that's not true, is it? Because if you half that root 6, we also can't do that using our maths laws. So going back to the question, okay, because we always read the question and sometimes we get ahead of ourselves. It actually, even though we simplified this fully, it wants it in root k. That's okay though, because we're practicing surds, aren't we? And it doesn't matter that we got 2 root 6, because we know that 2 root 6 is the same as root 4 times root 6, isn't it? Because 2 can also be represented as root 4. 4 times 6 is the square root of 24. So the final answer is root 24 because the question asked for it in that form. However, normally in the GCSE, it will ask you to put it in its simplest form, so the answer would be 2 root 6. It doesn't matter if we did this first and then go to this, or if we get this and we then go to this. The whole point is understanding, and it's all extra practice. Question 8. We need to be able to practice these skills again, okay? And then here is another one for you to try and simplify. The reason why we need to keep practicing this skill is you'll see in a moment. We're going to rationalize the denominator of a question where it's not just a single term. The term on the denominator will be, for example, 4 minus root 2. This is why this skill is so important to practice for the moment. Okay, so off you go, do this. Okay, question 9. So, with the show that questions, we physically have to show what's going on, okay? So we could lay it out like this. This is one example. Left-hand side equals 12 over the square root of 8, okay? Now, we need to rationalise the denominator. So I'm going to multiply this by root 8 over root 8. Okay, this is like a show that. We have to show every step. So on the numerator, we're going to get 12 root 8 divided by 8. Because root 8 times root 8 is 8. However, root 8 is equal to the square root of 4 times 2. Root 4 times root 2. 2 root 2. Okay? So this actually becomes 12 lots of 2 root 2 over 8. 12 times 2 is 24 root 2 over 8. 24 divided by 8 is 3 root 2, which equals the right-hand side, therefore proved. So you can see how I've started on the left, okay? Started on the left, I've gone through the motions, and then I've ended up with the same answer on the right-hand side. Now, some of you have seen this and you've started to solve this by multiplying by the denominator here and going about it that way. However, still right, it's not quite the right way to do this. It's better if we say left-hand side equals and we manipulate the left-hand side until we get to the right-hand side. This is the trick with these types of questions. Okay, this is a lot, this is going to be easier because sometimes, do you remember they had here, for example, what if it said show that 12 over root 8 equals, and instead of writing 3, they wrote k root 2. And it said find k. How we'd find k is we'd manipulate the left-hand side to get it into a form, something root 2. And then something root 2 equals k root 2. That means this must equal k. So it's a lot easier to do it left-hand side equals. This also works really well and is going to feed really nicely, this method, into when we start learning proof. So, if we have a look at part A, okay, have a look at part A, and then you'll see that part A leads us into part Q, which we'll speak about in a minute. So have a look at part A and expand that, please. Absolutely. So because this is 5 plus 3 root 2 squared, remember this means this is 5 plus 3 root 2 multiplied by itself.
And then we do 5 times 5, which is 25.
5 times 5 is 25.
And then what is 5 times 3 root 2, which is 15 root 2.
5 times 3 root 2 is 15 root 2.
And then for the third one is the same as 3 root 2 times.
And this is 3 root 2 times 5 again, which is the same.
And then 3 root 2 times 3 root 2 equals 18.
3 root 2 times 3 root 2. Remember, this is going to be, essentially, this is 3 times root 2 times 3 times root 2. We know that root 2 times root 2 is going to give me 2. So this is 3 times 3 times 2, which we know is 18. So some of us are doing that in our heads. Some of us are using a calculator to help us. And then 15 root 2 plus 15 root 2 is 30 root 2 and 25. 25 plus 18. 43 plus 30 root 2 is the final answer. Okay, the next part of the question is using manipulation. Okay, 43 plus 30 root 2. Okay, so we know that this equals 43 plus 30 root 2. And we want to show that P plus Q over root 8. Okay, we need to manipulate this. First of all, my 43 is linked to this one. Okay, and my 30 root 2 is going to be linked to this, isn't it? However, how can we manipulate this? Have a think about it. So, we know this 43 is going to match with this p. So we know p is 43. Then I need to arrange 30 root 2 to q over root 8. Okay? So, 30 root 2. And I want it in the form something over root 8. If we were looking at fractions and we had 4 and I wanted it in the form over 6, what would we do? We'll do 4 over 1 multiplied by 6 over 6. Because we're multiplying it by 1. We're not changing the quantity, and then we'd get 24. So with 30 root 2, what am I going to multiply this by? Square root of 8 over the square root of 8. The reason being is because root 8 over root 8 is a whole number, 1. Okay, so I'm not changing this. And remember, this is the same as saying 30 over 1. Okay? So, I'm going to get 30 root 2 times root 8, which is 30 root 16. Does anyone know what 30 root 16 is? 30 times 4 over root 8, which is 120 over the square root of 8. So therefore, we know that p is 43 plus 120 over the square root of 8. The happier we get with algebraic manipulation, the better. Okay? Now, just to say, I've never seen an exam question like this. However, I love the fact that David, who creates these exam questions, has them in this way because it gets us thinking. It's not just a typical, oh, everyone just multiply by root 2 over root 2. You know, we actually have to understand what's happening. Okay, question 11. I want you to do left-hand side first. This is your left-hand side. And once you've expanded and simplified the left-hand side, we're going to equate it to the right-hand side. Okay, we're going to equate coefficients. We're not going to rearrange. Just expand 5 minus root x, 5 minus root x. Once you've expanded that, we're then going to look at how this is similar to the right-hand side. Okay, so we just have to imagine it's a normal thing. Yeah? Okay, step 1. 5 times 5. 5 times negative root x. Negative root x times 5. Negative root x times negative root x. Stop. Plus first, isn't it? Yeah, plus negative times a negative. What is the square root of x times the square root of x? X. Perfect. So we have 25 minus 10 root x plus x. Okay, I'm going to simplify this a little bit. Okay. I'm going to put the numbers together and the roots together. So this is 25 plus x minus 10 root x. Is everyone happy how I've rearranged this? Yeah. Now remember, this equals the right-hand side, which equals y minus 20 root 2. Okay, so what we're going to do something now is equating coefficients. Okay, so y must equal 25 plus x, because this doesn't have a square root, does it? Okay, and 10 root x must equal 20 root 2, because I know there's a negative here, negative, so we don't have to worry about the signs, but 20 root 2 must equal 10 root x. Yeah? Okay. So, we're going to do this slightly different. I'm going to write these as two equations. I'm going to write 25 plus x equals y. And I'm going to write 10 root x equals 20 root 2. Okay, so here we go. First thing I'm going to do. Can I do anything here? No, because I've got an x and a y. I don't know. For this one, can I do anything? Yeah, I have an x. Okay, there's a million different ways now we could rearrange this, and however, I'm just going to go with what someone wants to do. What's the first thing you would do here? Divide both sides by 10. So the square root of x equals 2 root 2. Okay? What could I now do? Yes, I know that 2 root 2 is square root of 8 because I've done it so many times now. Okay? Or, if you didn't know how to do that, you know that 2 is the square root of 4 times the square root of 2, which is the square root of 8. So you can say root x equals root 8. So what does x equal? 8. X equals 8. Okay, so that's one way we could do that. Brilliant. Another way we could do this, okay, just, there's a million different ways. There is no right way, okay? I could do this. Instead of doing that way, I could say to myself, okay, how do I get rid of a square root? I square both sides. So x equals 2 root 2 squared, which is 8. So I could have gone that way as well. Okay, there's a few different ways we could have done this. And whatever makes you comfortable. So we know x is 8. Okay, if we know that x equals 8, okay, we can substitute that into here. What's 25 plus 8? Equals 33. Okay? So therefore, y minus 20 root 2, it says find the values of x and y. Our x is 8 and our y is 33. So what we actually had here was simultaneous equations as well as surds. Very nice question.